I've got a variety of equipment that enables me to do every wheel and tire service need that our vehicles have. I do tire mounting and dismounting, wheel balancing, and front end alignment, all in a limited space shop. In time, this equipment pays for itself. Testing light truck tires requires a vehicle that is square with the proper front end alignment and tires that are in balance and aired properly. To make sure of that, we do our own in-house wheel alignment. I will show you how easily a front end alignment can be done in-house or at your do-it-yourself garage. Tire rotation and basic front wheel alignment can be done with these tools. I use Gaither Wintec jacks, an SPC alignment set, the Fast Tracks, and the Gaither Wintec tire dolly and lift. The turn plates and other niche products were purchased at Amazon. The turn plates are rated 5 tons, which is more than enough for our Ram 3500 truck with a diesel engine and winch bumper. When shopping for turn plates, note that these turn plates have a wider base and are considered commercial grade. We'll begin with a 4-wheel tire rotation with 4 Wintec jacks and fast lock jack blocks holding the vehicle up securely. Note the positioning of the jacks with this beam axle vehicle. By using these 3-ton metric jacks and fast lock jack blocks, the vehicle is held up safely and much like jack stands, allowing space for working under the vehicle. Note that the jacks are angled inward on this sloped floor. This slope is very mild. If it is a steeper driveway, do not use 4 jacks. I rotate 4 tires and do not rotate the spare tire into the mix. I go rear to front and front to rear in cross. Note the small chocks at the jacks. This is a good time to check the rear brakes for any wear on lining or damage to the drums. I always use asbestos-free lining on my brake shoes and pads. This helps eliminate hazardous dust in the shop. This is the right front tire. Move to the left rear. And again, I'm going to take measurements to see if the tread wear is even. And it is. We have a nice wear pattern evenly and uniformly across the tire tread, which means that the caster camber and toe-in at the front wheels is still on. There's no sign of cupping along the edges, which would be indicative of shock absorber wear, so we're good to go. One of the advantages of performing your own service work, even tire rotations, is the opportunity to do safety inspections like the front brake pads and the rear brake shoes. We always check the brakes when we rotate the wheels and tires. These pads are in excellent condition, as are the rotors. We're good to go. There are guidelines for wheels, lugs, and wheel studs. I support the Wheel and Tire Council at SEMA, and their guidelines are excellent if you're unfamiliar with how to service wheels and tires. Matching wheel nuts with studs and wheels is especially important with the aftermarket products that most of us use. Here are the guidelines, including the pattern for tightening wheel nuts in cross. The front wheels and tires are now resting on the turn plates, and the turn plates can slip as well as rotate. You want to have both slip and steer when checking the front wheel alignment. At the rear of the vehicle, I will use the jacks because this garage floor is slightly sloped, which is very common with residential or smaller shop areas. So for checking the rear alignment, we would use slip plates, which I have a pair of, in addition to the front turn plates. And we would use these floor jacks to level the vehicle, which I'm going to do now. I'm going to verify that the vehicle is level. And why would I do that? Because I want the caster adjustment at the front to be accurate. And in order for caster to be accurate in terms of caster degrees, the vehicle has to be level. So I found from experience that these sills are pretty much the flat line of the vehicle. And I have here raised the rear of the vehicle to get this on level. You have to do both sides. Both sides must be uniform. The amount of distance from the floor that you see here is the thickness of the front turn plates plus whatever's necessary to level the vehicle. After a little back and forth, both sides are now level, as you can see from this bubble spirit on the body sill. So again, what we've compensated for is the slope in the floor plus the height of the front turn plates. The vehicle is now level. We'll take that one step further and make sure that the tire air pressure is correct as well. When it comes to tire inflation, I again rely on Gaither tools. I air these tires to 23 pounds per square inch, which may sound low, but these are load range 10-ply oversized tires. And 23 pounds is what is providing us with this nice, even, and uniform tire wear. If I ran anything more than that on this lightweight vehicle, which weighs around 3,700 pounds, I'd be running on the center of the tread. Instead, from experimenting and doing a little bit of math, PSI is the right tire pressure. All four tires are adjusted to 23 PSI. The XJ Cherokee has a unique suspension system, leaf springs at the rear, unlike a TJ Wrangler, and Lincoln coil suspension at the front, like a TJ, and in this case it's a 6-inch long-arm suspension kit. The Lincoln coil front suspension has been in here for almost 100,000 miles, and we've had no issues. The Heim joints, all of the movable features have held up really well. The shock absorbers are gas charged and they've held up well. This is a full traction suspension system, 6-inch long arm, which does require a drop pitman arm. Characteristic of a drop pitman arm, I have done a light rebuild and reseal of the Saginaw power steering unit. I've used this Fast Tracks system by SPC for years. I have 2 of these units, although you can get by with just one, that allows me to set up for both sides and quickly do a very accurate alignment. This all begins with leveling the gauges in their 3-point mount at the wheel. This is an essential part of doing the alignment properly. Both of the gauges are in place and aligned vertically. The first check is camber. And for the right front wheel, the camber is at just over ½ a degree negative, which is in spec. The left front wheel shows a camber of 3/4 of a degree negative, which is also right at the fringe but still within range. So we're okay there. I would be watching the ball joints from this point on. They may be showing some wear soon. They're not currently. To check caster, and we're looking for about 7 degrees of caster, we'll pull out the stops so that the turn plate can turn. With both of the pins pulled, the turn plate can now slip or go sideways as well as rotating. We've loosened the set screw for the vial. This is the left side, and the goal here is to turn the wheels 15 degrees outward. The end of the vial is V'd, and that V is now parallel to the body. This left front tire is turned outward to 15 degrees, and at this point, we will zero the vial. The vial is zeroed. The turn plate is at 15 degrees with the left front tire pointed outward at its front. We will now rotate this left front wheel until we are 15 degrees inward with the front end of this tire. The left front tire is turned inward 15 degrees. We read the vial at this point, and the bubble is at 8 degrees positive caster. This is just about the limit for positive caster and will work really well on a trail-driven four-wheel drive vehicle. The right front wheel is turned out 15 degrees now, and we're using the turn plate. We zero the gauge at this point. We'll now rotate the right front wheel so the front of the wheel and tire is pointed inward 15 degrees. We're rotating 15 degrees inward. We'll read the caster degrees at 15 degrees inward. And we're once again at just over 8, about 8 1/4 degrees. And this is ideal. We had the steering wheel stop removed when we checked the caster because we had to turn the front wheels. So now we'll turn the steering wheel back to center. This wheel was on center to start with. So we'll put it back on center and install the steering wheel stop. This way, if we do have to adjust the toe in, we'll know where the steering wheel center is. Checking the toe in is straightforward. Involves the use of a tape measure at the front and rear side of the gauges. SPC sells these gauges individually, and some people manage to get away with one gauge that they move from one side to the other. I find it much more practical to have two gauges. We take an accurate measurement here. Set on the wing. Don't pull on the wings. You'll distort the measurement. Do not pull on the wings and make sure that the gauges are both fitted snugly at the rim. We have 82 1/8 at the front. We measured 82 1/8 at the front. And at the back, again, just laying the tape on and not pulling tightly, we have 82 1/4, which means the wheels are towed in 1/8 of an inch. And I'm actually okay with that. 0 would be great if I wasn't running oversized tires and the front end had less miles on it than it does. That 1/8 inch of toe in, we can tell from the tire wear, which is non-existent, is actually right in this case. And we're going to leave it at an 1/8 inch toe in, largely due to the oversized tires and to compensate for any wear in the steering joints or the ball joints. Factory toe in calls for minus 0.10 to positive 0.25 degrees. I'm good with 1/8 of an inch of toe in to compensate for the oversized tires which create more resistance on this older steering linkage and ball joints. So that's going to do it for this routine tire and wheel alignment check. And we'll disassemble the gauges. Handle the gauges with care. The vials especially are expensive and are glass. They're vulnerable to breakage. There's no reason to suspect that the thrust or rear wheel alignment is out. This is a beam rear axle with leaf springs that are fixed at anchors at the front end of the springs. The only thing that would knock the rear out of alignment would be a broken spring bolt, sagging springs, worn anchors and other suspension joints, or a bent frame. This is a unitized body vehicle that's never been damaged, and so we are in good shape with regard to the four-wheel alignment. I'm not going to bother checking it. There wouldn't be any point. If I had a need to check four-wheel alignment, I would put the slip plates under the rear wheels, and I would use strings and check for diamond equal lengths in cross from front to rear. If anyone's curious about that, I can explain the process. Leave your comment at the YouTube channel or contact the 4WD Mechanics forums.